Alright, so this video is going to cover questions 1 through 4 on the quadratics test, putting it together because each question is kind of related to the same theme. And the story that we're talking about here, so we're talking about drinking Red Bull, and we're talking about how much caffeine is in your bloodstream over time. So what we're thinking is that at the very beginning you don't have any caffeine in your system, and then as you drink it, right, the caffeine is going into your system, and then but once you finish the drink and as time goes on, your body processes out the caffeine and then it goes back down. So we're thinking that it's going to have some sort of shape like that, where it starts out at nothing and then it peaks and then goes back down to nothing. So what we're going to do is that we're going to first of all start a graph, and I'll erase that. That was just a little bit of a sketch. So what we do have though is that our independent variable is time, and that time is being measured in hours. And our dependent variable, our y, is the concentration, as far as how much caffeine do we have. So this would be concentration. And then we always want to label the units. So in this case, we're talking about milligrams per liter. And that would be if we drew a liter of blood, there would be X amount of milligrams of caffeine, right? So that's what we're saying. How many milligrams of caffeine would be if we drew 1 liter of blood? So a couple of things we could do is that we could sketch this just even without even using the calculator. If I look at my time intervals, it looks like we're counting every half hour. So what I could do is that would be 1, 1.5, 2, 2.5, 3. And it looks like we go up to 2.5 hours. And then, on the y-axis, it looks like we're the highest we get is maybe somewhere close to 80. So we could count like 10, 20, 30, 40, 50, 60, 70, 80. So let's say that's 10. Let's say that's 80. That's maybe a little hard to read. 10, 20, 30, 40. If space is tight, we don't always have to mark or label every one, but we do need to mark it. So the first one, it says 0.5. So in half an hour there was roughly 43. So we're just kind of estimating here. So maybe something like that. After an hour there was 78 milligrams. So looks like we get pretty close up there. And after an hour and a half, it looks like it starts actually coming back down. So we'll maybe say something like that. By 2 hours, it's dropped down to 58. So maybe something like that. And then after 2.5 hours, it's dropped down to 32. So it's not the perfect U shape that we maybe first suggested, but you do get the idea of something going up and then it coming back down. But what we're going to do is that, and I'll erase what I just did there, we're actually going to leave it as a scatter plot. So we're going to leave the dots. So what we're going to do here, because we don't know exactly, we just know certain points in time. We can't say that we know after 45 minutes where it was at, or after an hour and 20 minutes. So we're not going to connect the points. So that's why we call it a scatter plot, is we don't connect the points, right? Now, what we want to do, though, is that if you look at question number 2, is that it does say, determine the equation for the curve of best fit. So what that's saying is it's saying, if we were going to connect the points, what would that look like? Well, so the first thing we're going to do is we're actually going to start with our calculator. And it's always a good idea to reset the calculator. I'm going to hit second, the blue key, plus for where the memory is, and then 7, 1, 2. And all this does is it just resets the calculator in case someone that was using it before you screwed around with it and put stuff in there. So we're just wiping it clean. So we want to actually copy this table into our calculator. So I'm going to go Stat, Edit, and L1 and L2 are going to be my 2 lists. So L1 is going to represent my x's. So I'll type in the x's. I've got 0, I've got 0.5, I've got 1, 1.5, 2, and 2.5. And for my L2, that's going to be my Y's, the amount of caffeine. So we start off with 0 before we started chugging that Red Bull. And then it's going up, 43.2, 78.1. On this, if you make a mistake, you can always just scroll back and type over what you did or hit delete. Right? So if you make a mistake, you can always go back and fix that. And 32.1. Alright, so one thing I want to do, we actually already have the graph, but I just want to show you that you could do this in the calculator as well, is that if you go to second y equals, and just hit enter on the first one here, we can turn on the plot, which turns on this special kind of scatter plot that we have. And actually nothing else I need to do, I just need to make sure that it's turned on. And then I need to tell the calculator what kind of view that I want. So I'm going to go to zoom. And a scatter plot is a type of statistical graph. So I'm going to go down to zoom 9, where it says zoom stat. You could also just type 9, you don't have to scroll. And then I'm going to hit enter. And then what I notice is that I get a picture. So let's compare. So this was the one I kind of sketched out by hand. It looks very similar to the one that we've got with the calculator. If you want to, you notice that it doesn't show the numbers. If you hit trace, it'll actually let you scroll through the points. And again, you'll see that these numbers matched up with what we've got in the table. Alright, so, but we already did that part by hand. I just wanted to show you that you could do that as a way to kind of check your answer, make sure you did it correct. What we want to do, though, is we want to figure out, if I were going to connect these points, how exactly would I do that? Well, we let the calculator actually do that part of it instead of us just kind of eyeballing or just kind of guessing. So what we're going to do is that we're going to go stat. And what I want the calculator to do is I want it to calculate the equation that's going to fit those points. And you notice 4 says len reg, that's for a line. Well, what we have is not a line, it's not straight, it's actually got a curve. So that's where we're going to say quadratic, number 5. So hit enter, and everything here should be kind of set up for you already as you need it. The one thing that we're going to want to do is that the equation that the calculator comes up with, we're actually going to want to save that so I don't have to retype it in. So where you see where it says store, I'm going to go vars for variables, and I want to save it as a y variable, and it's a function, and I want to save it in y1. So notice what this is going to do is that when I hit enter, it gives me an equation. So let me write down the equation here real quick. So we've got y equals, and we could do some rounding here. So let's say negative 40. We'll just round to the nearest whole number. Negative, actually not 0.4. So negative 40 x squared plus 111x plus, let's say 0.19. Okay. Now you notice though what happened is that I rounded all of that because I didn't want to have to write all that in. So this answer becomes a little bit less accurate because of the rounding. So because I want to be as accurate as possible, what I did is that by doing that vars, y vars, what I've done is that if I go to y equals, that equation is now stored in there for me. So I didn't have to retype all that in. So what happens is that when I go to the graph, so I just hit graph, the calculator is now going to draw in what it thinks is the best way to try to connect those points. Now you notice it doesn't go through all of those points, but it goes through most of them and pretty close. So it's not a perfect fit. That's why we call it the best fit, right? So it's not perfect, but looks pretty good. So what we want to know is at what point was the highest level of concentration of caffeine. So what we're looking for is that we want to know with our little curve here, and let me just draw a sketch, is that with our little curve, we want to know what's the highest concentration. So we want to know what is that point right there. Like how much, and by looking at the table, you might think, well, maybe it's in the 70s, maybe it's 80, something like that. Well, let's use the calculator to tell us exactly what it is. So what we're looking for is we're looking for the vertex And the vertex in this case is the highest point, which we call the maximum. The vertex is our fancy math word for the turning point of a parabola. So in this case, the parabola is going up and up and up and up, and then it hits a high point, and then it comes back down. So we want to know what's the maximum. Well, I can actually have the calculator do this work for me as well. So what I'm going to do is I'm going to go second, the blue button, trace, and I want it to calculate. And what I want it to calculate is I want it to calculate the maximum. I want it to tell me the highest point. So when you do that, you'll see where it'll say left bound, and it's wanting me to set a range of like, okay, look in between here and here. So I want to be somewhere on the left side of the little hump. It doesn't matter exactly where, just somewhere on the left side. And then it's going to say right bound. So that means that I want to be somewhere on the right side of the hump. So I'm going to scroll to the right. So that's still kind of in the middle. Let me keep scrolling. Okay, now I'm on the right side. And then it says, do you want me to guess? Yes, that's the whole point. So hit enter, and it'll give you a number here. It says the maximum, and we could round here a little bit, but so it says the maximum is at 1.4. So let me write this in over here. So we're saying that the maximum is at 1.4, and the y value there is 77.9. So let's say 70. Well, we could say 77.9. Or we can say 78. We round there. So what this means, so what does the 1.4 mean? Is that how much concentration? No, that was time. So what that means is that when 1.4 hours is when it hit the highest point. So what we could say here would be approximately 78 milligrams per liter, right? And we want to make sure we put our units on there. All right, and then the next question says, how long did it take for the caffeine to leave the bloodstream? So again, if I drew myself a little curve here, what I'm saying is that here was the high point. How long did it take for the caffeine to get out of the body? So what I'm looking for is I'm looking for that point when it hits 0. So what I could do is that I can then say, well, let me go back, and I'm going to do second trace. This time, I'm not looking for the maximum. I'm not looking for the highest point. I'm looking for it when it hits 0, when there's 0 caffeine in my body. So that would be number 2. And now, the place that we're looking for, if you look at where my cursor is, right, I can't actually quite tell where it actually lands. So what I need to do is that I need to adjust my window. I need to kind of zoom out a little bit. So it looks like that this thing cuts off at 2.75 hours. Let me just make it a little bit bigger. So I'm going to say, let's say if we put that to 4, for instance. No particular reason why I picked 4. We're just kind of playing with it. So I then go back to graph, and I can see, oh, okay, so now I see where it actually crosses. So again, the problem was, let me go back just to compare. So the problem was is that as it was, the calculator wasn't showing me where it actually bottoms out. You see how we barely are not seeing that. So the window is what lets me tell the calculator to zoom out a little bit. I did 4. I don't know. Let's see if 3 would have worked. If I did 3, yep, I can see it. So don't stress about the number. The point is we just want to see where it crosses. So I'm going back to second trace, and again I'm looking for the 0. Now you won't always have to adjust that, by the way. It just happened to be in this problem that we did. So my left bound is going to be just a little bit where I want to put the cursor. It's just a little bit above the x-axis, because I'm looking for where it actually hits 0. So I want it a little bit above, and then my right bound, I actually want it a little bit below. So you see how the y value is now negative? So I'm kind of sandwiching this location. And then I want you to guess? Yep, that's the whole point. And so what we get for a point is we get 2.79. Well, we can maybe say 2.8. And you notice it says negative 4e, negative 12. That's just putting it in scientific notation. But that point is 0, so don't worry about that part of it. So how long did it take? Well, it took approximately 2.8 hours. And that should make sense because at 2.5 hours, we still had 32 milligrams in. So what we're saying is that if we just a little bit more time passed, it's out of our system. All right, so I know that was a little bit of a long one maybe, but we took care of 4 problems, and they were all related to one another. So go ahead and stop the video now and try 1 through 4 on the right side.